Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 277. Page 277, and today is our lesson number 40. Today is our lesson number 40, the very first problem in the second column. The very first problem in the second column is problem number 30. They give us a little cylinder. Let me reproduce it here. They give us a little cylinder, and the question simply is, what's the surface area of this band? What's the surface area? What is the surface area of this band? The first statement tells us that x equals half a meter. X equals half a meter. This part right here. Now let's first talk about what the question is actually asking. What does it mean, surface area? Well, surface area means exactly what it says. It means area on the surface. Except over here, this area on the surface here actually is this tiny band here. Think of this as some sort of a band that you put around it. If you were to take that band off the can, think of this as a can, and there is a little sort of a label, manufacturer's label around it, which you can easily, sometimes they don't do a very good job and you can take them off, and if you were to take it out and spread it, it will look like a long rectangle. This is what you're looking for, and this distance from here to here, once you open it and spread it, that represents the circumference. Circumference of the circle, the distance all the way around it, this distance all the way around it. And this is what they're calling us x, this is what they're telling us, x meters. Or rather, yes, I'm sorry, half a meter. Not x meter, but half a meter. Well, they do call it x meter, but in the first statement they tell us that it is half a meter. Now we know this is half a meter wide, but how long is it? That has to do with the circumference, which is circumference equals to pi r. Somehow, somewhere, we have to figure out either the diameter of this bloody thing or the radius, which of course is one and the same. They do not tell you anything at all about the diameter or the radius. The first statement by itself does not do the job. It is not enough. AD, BCE. AD, BCE. Since the first statement does not do the job, answer cannot be A or D. We need to figure out the radius of this cylinder. We need to figure out the diameter of this cylinder somehow. Let's look at second statement. Second statement tells us the height of the tub is 1 meter. Oh hell. The height is 1 meter. That does us no bloody good. The height is 1 meter. That does us no bloody good. We're not interested in the height. We're not interested in the freaking height. We want to know the radius. This is useless information. This is useless information. Knowing the height of this thing, how is that going to help us find the radius? This is what we're interested in. We need the radius here, 2 pi r, because that length is the length of this band when you open it. They do not tell us the thing. The second statement by itself is also no good. The answer is E. The answer is E. That's all. That's it. We're done with this one. Let's do one more. Shall we? Let's do number 31, the next one. That's it. We're done with this thing. We don't have the radius, and without the radius we cannot figure out the circumference, and without the circumference we don't have the length of the band, and without the length of the band we cannot figure out the surface area of that band, which is the area of the band of the rectangle. Number 31. In 31 they give us this decimal. We are told that d equals 0.43t7, and the question simply is, what is t? And of course t represents the thousandth digit. It represents the thousandth digit. In the first statement they tell us d rounded to hundredth digit, d rounded to hundredth digit equals 0.44. Well, let's write this down here. D equals 0.43t7. And when you round it to the nearest hundredth digit, we are told that this equals approximately 0.44. What that tells us that this t, because it's been rounded up from 3 to 4, that tells us that the t must be something greater than or equal to 5. Now that's a gray area where it's equal to 5 or greater than 5, but the point is we do not know exactly what it is. All we know is that it's greater than 5, or if you insist, equal to or greater than 5. But knowing that something equal to greater than 5 does not exactly tell us what it is. It does not. It is not enough. The first statement by itself is not enough. A, D, B, C, E. A, D, B, C, E. Since the first statement by itself is not enough, cross out A and D. Let's look at second statement. Second statement tells us that D rounded to nearest thousandth of the digit equals 0.436. Aha! Voila! Now we're getting some place. D was 0.43t7. When we round it, now we are told that it becomes 0.436. Well, that makes life very easy. This t is now 6, which means since we are rounding it up because this is more than 5, 7 is more than 5, so we are rounding it up, that's the important part. So t must have been 5. This implies that t must have been 5. It was 0.4357 to begin with. And we're rounding it up to 0.44. Voila, t is equal to 5. Second statement does the job. Second statement does provide us sufficient information. The answer is B. The answer is B. That's all there is. That's all there is. I will see you tomorrow and we'll continue our journey. Okay? Bye now.